Today we're going to expand upon what we started in the last chapter, and we're going to use that information to help us write and graph linear inequalities. Today is going to be a lot of graphing, so after I'm done teaching the lesson, remind me to pass out some graph paper, somebody, because you'll need it for today's lesson. Finding it down ALC. Yeah. I'll be writing it up. Okay. Right, the first thing you're going to have to do when we look at inequalities was the first thing we did when we started looking at equations, which is when we had the equations, I'd give you a specific number and say, does this number satisfy the equation? Something like this. And then I'd ask you, does 1 satisfy the equation? Does it? Does 1 satisfy that equation? How do you know? You just put 1 in for x, right? Is that what you're telling me? You did? Yeah. So what do you suppose we would do here? We've been given a coordinate, we've been given an x and a y, and I'm asking, does this satisfy this inequality? How do you think I would solve that? I'm sorry? Exactly. Plug in 6 for y and 2 for x and simplify and see if I get a true statement when I'm done. So we're asking, is 6 greater than or equal to 2 times 2 minus 1? So 2 times 2 is 4. 4 minus 1 is 3. Is 6 greater than or equal to 3? Is that true? Yep. So that means, yes, 2, 6 does satisfy that inequality. What does that mean to satisfy an inequality? Well, just crudely and very quickly, when you satisfy an inequality, what you have when you graph an inequality is something like this. 2x minus 1 would look something like that. And then greater than would mean you shade up here. And we'll get to all the shading and everything in a minute. But what that means is when something satisfies an inequality is that in the shaded region, that's where the ordered pair is. 2, 6 would be something like right up here. Is that point in the shaded region? Yes. So that's what we have when we have an inequality. We have not just one ordered pair or some ordered pairs on a number line, on the line like we did with the equation. We have a whole group of ordered pairs. Just like when we were solving inequalities, remember we had the number line and we would shade with an open or closed circle and draw the line less than. If it's less than to the left, greater than to the right. So now we have to shade not only one direction, but 2. We have to shade left or right plus up or down. So that's why we'll end up shading a whole region. We'll get to that. But anyway, this is what I want you to see. This is what it represents. When something satisfies an inequality, that means it lies within the shaded region for that inequality on the coordinate plane. All right. What would I do here? Okay, don't everybody rush to speak at once. What would I do here? Okay. Exactly, yeah. Here's my x, here's my y. I'll substitute those in. So 4 less than 2 times negative 2 minus 1. So what we're asking is 4 less than negative 4 minus 1 is 4 less than negative 5. Is that true? No, it's false, right? Because there's no way a positive number, any positive number, could be less than a negative. So this is false. Which means, does this satisfy the inequality? No. So if we were looking at this example here, it would be on the other side. It would not fall within the shaded region if we were looking at a graph. All right, so we're going to use the stuff we learned in the last lesson when we were graphing equations for the inequality. So for the first thing I want you to do is, let's pretend this was an equation. So we'll put a little equal sign in there to hide the inequality. If that were an equation, what would I do to graph that line? Yeah, plus 2 means I go start at the origin and go up 2. There's my first coordinate. That's the y-intercept. Now from there, what is the slope? It's 2 over 1. Good. So we make that a fraction. The top number stands for the rise. The bottom number is the run. So from the point I just put, I go up 2 over 1. There's my next point. Now I could keep doing that up 2 over 1 as many times as I want. But how many times do I have to do it? I have to count for the slope at least once, right? Because I have to have 2 points to determine the line. Now, if this were an equation, what would I do now? If this were an equation, what would I do? Just draw my line, right? So if this were an equation, I'd be done, correct? All right, now we have to turn it back into an inequality and find out where it's different. Right, if that would have been an equation, I would have drawn my line and been done. There are two differences having an inequality. The first difference is the kind of line. There are two possible, so we'll pull that off to the side. We could have a graph with a solid line, or we may graph with what's called a broken or dashed line. I don't care which term you use, I'll just say dashed. So in order to figure out which one goes with which inequalities, now remember we have 4 inequalities, right? We have greater than, we have less than, we have greater than or equal to, and less than or equal to. So let's go back and think about when we were just solving inequalities with one variable, just with x. We had 2 different kinds of points we used to graph those. What were the 2 kinds of points we used? Open and closed. This inequality, the inequalities alone got what kind of point? Open or closed? Open. Less than or equal to, greater than or equal to. So the inequalities with an equal sign got closed. All right. So that's what it was when we had one variable. Now we have 2, so we have to use a line. Which ones do you think go with the solid line? Those that go with the closed point. So greater than, good. Greater than or equal to? And less than or equal to. So anything with the equal in there is going to be graphed with the solid line, which means that greater than, come on, and less than, just the inequalities, you graph with the dashed line. That is the first difference. So I went ahead and plotted my points. What kind of line should I have? What kind of line should I use to graph a dashed line? I should have used a dashed line to graph this because it's just the inequality. All right, so I'll go ahead and get my dashed line and graph it. All right, the second difference is because it is an inequality, I have to shade one side or the other to represent all the ordered pairs that would make it true. So it's greater than. What do you suppose greater than? You pretty much have 2 choices, above and below. And I'll show you how to get the above and below. What do you suppose greater than would represent? Above, and less than? Below. All right. So I look at this, and I have greater than, so greater than would be above. To figure out which side is above, I go to the y-intercept. That is almost always a place where you can find an above or below, right there on that point. So above would be on this side. I make a little mark. That tells me I need to shade this whole region right here somehow. All right. And that's it. So those are the 2 differences. Now, can somebody tell me what this dashed line means? Why would I have a dashed line here? What about all these points? Yeah, it won't be any of those on those points. Let me show you why. The reason why we use a dashed line is similar to why we used an open point. It means don't include this point or these points, because here's what happens. If you would choose a number on the line, let's choose the y-intercept. This is the point 0, 2. If I put those in for x and y, I get 2 in for y is greater than 2 times 0 plus 2. What's 2 times 0? 0 plus 2 is 2. So is 2 greater than 2? No, it's equal to it. So any number that's just bigger than 2 for my y, 2.0000, and eventually throw a 1 on the end, and it would be true. So any of the numbers on this dashed line, we don't include those. They would not be part of the solution set. almost, but not quite. But that's why it's dashed. We don't include them. All right. What would I do here? Well, the first thing I like to do is I like to figure out and then mark, do I have a solid line or a dashed line? So look at the inequality. Would it be solid or dashed? Solid. So I'll make a little note to myself. I need a solid line there when I graph it. And I'm going to start at the origin. Where do I go from the origin? Why am I going down 3? It's negative 3. Good. So my y-intercept is negative 3, so I go down 1, 2, 3. Make my first point. Now from there, where do I count? From that point, 0, negative 3, where do I count? I'm sorry? He says up 1 over 1. Why? Very good. There's the slope, the number in front of x. We don't see anything, so it's the number 1, which means it's a fraction. It's 1 over 1. So the rise is 1 and the run is 1. Up 1 over 1. And I already denoted that I need a solid line. Put that in my... Now I just have to worry about shading. Do I shade above or below? It's less than, below. So I'm going to go to the y-intercept. That side is below, which means this is the side that gets shaded. Kind of like below and to the right. And that will work on every case with one exception. What is the one kind of line that's not going to have above or below? Vertical. A vertical line will run this way. So vertical line, this side is less than, the left is less than, and the right is greater than for a vertical line. You know, horizontal is definitely above and below, but that's the only exception to that. Now these are the forms. Now we've already mentioned all these things, so if you're going to put these in your notes, I would put just a shorthand version of them. This just talks about where you shade and what kind of line. And it's all stuff we've looked at already. So if I have, and this is greater than, so what I would put in your notes is if it's greater than, I shade above with the dashed line. If it's greater than or equal to, it's above a solid. Less than would be below a dashed. Less than or equal to, below a solid. And I would just put shorthand in there like that. Save yourself all the writing. But those are the 4 possibilities you can have whenever we graph an inequality. 2 different kinds of lines and 2 different places to shade. You'll see. Is that the first time? I agree. All right. Good luck to you, sir. Yeah. Good luck. Good luck.
Has it been attempted? Might stand a decent chance. Don't have an argument to it yet.
All right, let's graph this one. Is this in slope-intercept form? That really should be your first question before you determine any kind of line or anything, because as I look at the homework tonight on page 260, I see that there are two that are not in slope-intercept form. So the first thing you're going to have to do is make sure you have it in slope-intercept form. Is that in slope-intercept form? Do I have y by itself on the left, x on the right, plus or minus some number?
No.
Exactly. What is the y-intercept if no number is written there? No, that's the slope. Right, 0. So if you don't see a number there, it's plus or minus 0. It doesn't matter. So right there's my y-intercept. It's going right through the origin. What's the slope? 1 over 1. So I go up 1 over 1. What kind of line? Dashed. It's a dashed line because it's just the inequality. A linear line. That's like going into a restaurant and asking for some wet water. Can I have that water that's wet, please? Or a round circle. Yeah. Yeah. Then it would call. Then it's called an ellipsis. An ellipse. What is that? An oval. Isn't that called an ellipsis? I don't know.
I guess that would be the more technical.
Maybe. I'm sure there's somebody here on the internet and point out that I'm wrong. They'll email me. It happens. They have too much time. All right. Now I have to worry about last step was to figure out the shading. So let me get out something. Let me show you another kind of shading I can do.
I don't know, I'm feeling flowers.
How about the stars?
Stars are fine.
Stars. All right. Above or below? Below. It's less than, so I go to the y-intercept. That's the below side. You like that? You know what that means, don't you?
You would have that set up.
So I'm an all-star. I'll maybe later. If not today, definitely tomorrow. Me. Somebody with too much time on their hands. That's because it hit me first period, so I set it up first period, and I played it for them, and they just kind of look at me because they're first period, like, yes, yes, you are. All right, what would I do with this one? Graph it. Well, technically, that would be the ultimate goal, right? To graph it, but can I graph it as it is? No. Right, it's not in slope-intercept form, so how do I get it to slope-intercept form? Subtract x. First step, even with inequalities, if it's not in slope-intercept form, I have to move x over first. So I subtract x from both sides. I get y is greater than or equal to negative x plus 5. Am I in slope-intercept form now? Yes. Now, I want you to be careful when you're working on your homework. Please open your textbooks to page 260. And look at problem number 7. 260. You're welcome. Problem number 7, 260. Problem number 7. Now, when we were solving inequalities, what happened when I had a negative sign out in front of x? I had to change my inequality, correct? Well, this one has two variables. So which is the variable that would change the sign? The y. Exactly. So if there's a negative sign out in front of the y, when I would change y from a negative to a positive value, that's when I'd have to flip the inequality. So look at number 7. Does number 7 have a negative sign out in front of the y? Yes. So eventually that negative sign in front of the y would flip the inequality from greater than to less than. Now if you look at the homework, 5 through 10, you don't have to graph those. You're just telling me where would I shade, above or below, and what kind of line would I use. dashed, or solid. So yeah, that would be solid, right? Same thing in 15 through 18. You're not graphing those either. You're telling me where would I shade, above or below, by looking at the inequality, and then what kind of line would I use? Yeah, the ones you're going to have to graph are 11 through 14, and then 19 through 30. So be careful on number 7, and then number 13 has a negative y. Those will change your inequalities. No. I don't know that I ever assigned. Yeah, I never assigned them.
Is that because the answer is in the back?
Yeah, exactly.
Right on.
I didn't know that. Me neither. Can we do the odds then?
No. All right.
That was my flaw. Sorry.
That's okay. Plus 5 means to do what? Up 5. There's my first point. And then what is my slope? Negative what? Negative 1 over 1. So what does that mean? That means I go where from that first? Down 1 to the right 1. Now what I make sure I always do is I always make sure I put my negative sign with the top number. That way this bottom number is always positive. So when I'm graphing, whether it's equation or inequality, I'm always going to the right for the bottom number. So down 1 and 1 to the right. Okay, what kind of line? Solid, good. And I shade where? Shade where? Yeah, on the right side, good, above. That's right there. It's very bright.
It's like an acid trip on the scoreboard. Colors and pictures and
All right. Is this one in slope-intercept form? Yes. So plus 1 means to go where? Up 1. So my first step when I'm graphing any equation or inequality is always to take my y-intercept, and that tells me where to go from the origin. Now from this point I just made, what do I do for the 1/2? Up 1, right 2. What kind of line? Solid or dash? Bless you. Dash line? Bless you. And where do I shade? Above or below? Where do I shade? Above or below? Above. Greater than. Greater than means above. So I go to the y-intercept. Above is that side. That's above the point. This means this is the side that gets shaded.
Get excited, Steve. Get excited.
Just ignore it. 216, 261, 1 to 30 all.